Hello and welcome to Unit 4, Conservation of Energy, Lesson number 5, Conservation of Mechanical Energy, Example number 3, which is the last of the 3 videos or examples in the Lesson 5 series. Okay, so what we have going on here is we have ourselves a little situation with a block that starts out on a hill and it has some initial velocity. This is a 250 gram block. Well, I changed it already to 0.250 kilos, something that we can use in our formulas. And it is sliding down this hill. Now, the question is, so when it slides down the hill, it collides with a spring. This is sort of like a bumper or something. And the spring is going to compress down and stop the block. Alright. Things that we know about the spring: it tells us the spring constant is 276 newtons per meter, and it also tells us that this spring compresses 0.162 meters. It's just 16.2 centimeters, but again, I converted that into meters. Alright, so we know mass of block, initial velocity of block, and a couple extra things about the spring here. We also know that the velocity of the block here, let's switch to blue to indicate block, the V final of the block here is equal to 0. Alright, the question's ultimately asking us, how high did this block start? So really, it's asking us to solve for potential energy and then use that value to get the height. Alright, so let's begin. We're going to use the same formula we've been using over and over here. I think blue is a pretty good color to use on this one. Let's do energy mechanical before is equal to energy mechanical after. And we can start talking about what we have. So initially here we have a block with velocity and also height. There's no springs before though, right? Spring is only over here. So before, we can say that because we have velocity, we have kinetic energy initial, we also have height, so we're going to have potential energy due to gravity initial. And then after, well, this block no longer has any height, so potential energy is out. This block also comes to rest, so kinetic energy is out. All this block has at the end is spring energy. Alright. And that's final. Okay, well, this question is halfway solved. This is honestly the thinking part of this question. Now we can just start filling in our formula, putting numbers in, and finishing it off. Okay, so we can say that kinetic energy initial is 1/2 mass times velocity squared. That's an initial velocity. Plus mass times gravity times height initial. That's what we want to solve for. Is equal to energy due to springs. This is our first time in this unit using spring energy. So our spring energy is equal to 1/2 kx squared, which are given to us by the question. Alright, now we could choose to rearrange and solve, or we can put numbers in and just do some algebra. I'm just going to put numbers in and do some algebra, and honestly I'm not going to show all of my algebra. So here we go. Let's do 1/2. I better move over because these do take a lot of space. 1/2 times mass, so 0.25 kilos squared. That's our initial velocity. Oh, no, that's not. That is our mass. Our initial velocity, 1/2. Oh yeah, no, I did want mass. My bad. 0.25 kilos times our initial velocity squared. That's what I'm going for here. So 3.8 meters per second. It's a squared value. plus, again, mass, so 0.25 kilos times gravity, 9.81 meters per second squared, times height. Well, we don't know height, so I'm just going to leave h here. That's what we're looking for. Don't lose that. Is equal to 1/2 times k, so that's 276 newtons per meter, times our x value squared. So this was, remember, given in centimeters. Make sure you convert to meters. So we have 0.162 meters and square it. That barely fit, but it worked. All right. Now you're going to solve all the terms, rearrange them, subtract whatever has to be subtracted from whatever. I'm going to draw some ellipses here because that solving is all on you in this case, and I'll give you the final answer. I get a height that works out to 0.741 meters. And again, I am fairly confident in that answer. So if you don't get it, this is another danger zone situation with the math here. So maybe I'll write that in here. Whenever we have, again, a lot of numbers flying around and being put into calculators, this is some danger zone. So if you ever have time left on the end of your exam, go through, redo these calculations, these big algebra sets. It's very common. I take marks off, small marks off all the time for people just having calculator errors. So with that said, that is the last example, example 3 in conservation of mechanical energy.